Hey, what's up, viewer? Welcome back to this Pong tutorial series. This is video 2 of 3 for visual scripting, and in the last video we covered using the visual scripting graph to make our UI builder buttons responsive to player clicks. In this video, we're going to use the visual scripting graph to respond player keyboard inputs based on the buttons we bound in Unity's input system. As I've been studying to do this, there are a few things I've discovered along the way. So we'll have to make a few modifications here and there. However, I have figured out a way to get this all to work properly. So without any further ado, let's begin. The first thing we are going to do, since it's pretty straightforward, is we are going to give the player the ability to toggle the pause state from within the game scene or from within the pause scene. So the first thing we need to do is come over to our visual scripting folder. I'm going to select the pause screen script graph. I'm going to push Ctrl D. I'm going to create a new script graph. So now I'm going to rename this to game screen script graph. Then I'm going to double click on the game screen script graph, and then I'm going to remove everything that's inside of it. If I take a quick look again at the pause screen script graph, essentially what happens here is we get the UI visual elements to respond to these buttons. However, there is one part that is missing. While we can push the return to start button to go to the start scene or push the exit button to close the application, what this is lacking is the ability to read the player's input for pushing the escape key for closing the pause scene. So there is a certain node combination we can do here to actually make that work. The first thing we're going to do is right click on the graph, open up the fuzzy finder, and we're going to type something called scene manager. And we're going to say load scene. This gives us the ability to pick a scene by name to load, so we're going to select this one. And the scene name we want to load in this instance is actually the game scene. From this point, we have to find a way to actually respond to the player pressing a certain key. And the way we can do that is we have to generate a certain node, which is actually provided. So we will right click, add node, and we will say input system, and then we'll pick this on input system event button. And on pressed, what we're going to do is load the game scene. So far we have this is actually going to check for whichever player input this graph object is on. However, there's a little bit of a bug I've discovered where if you try to go down this route, even if you select here, let me minimize this real quick. If I click on the main camera and then I click on scene variable, it's not actually showing up here, but it is supposed to look for in actions. And actually, let me click replace real quick, and I'll do on input system event button float. And let me revert it back again to try and force it to actually show this properly. And in this instance, it's not even doing me the courtesy of showing it properly. And I think the reason for that is actually because I'm on the pause scene graph. So we're not going to worry about it in this example. I'll show you in the next one on the other scene. Essentially what happens is it will give the option to pick whichever action you've defined in your input graph or in your input system. However, there's a bug where once you enter and exit play mode, it will mess this up. It breaks the reference, and you won't be able to choose a new action, and it will forget visually which action you've picked. And it's really very strange because the behavior will still exist, but the actual node itself gets a little funky. So instead of using the built-in functionality on the node, instead what we're going to do is actually plug it directly into these ports. So to do that, the first thing we need to do is actually gather a player input variable, which if I real quick open the scenes, go to the pause scene, click on the main camera, and we take a look, our pause scene does not actually have a player input, so we need to make sure that we go to the camera, click add component, and add a player input module. I'm going to drag this up for a little bit of organization, if it will allow me to drag it up without getting futzy. Okay. Now that we have the player input, we have to select an input action, and that input action is player input still. And all this is still good. Now that we have a player input in the actual pause scene, we can go back into our pause screen script graph. We can click on scene, and we can create a new variable name, and we are simply going to call it player input. Then we need to pick a type, and that type is player input. However, note that by default, we do not have the option to use a player input type, and that is because we need to go to our project settings by clicking on edit, project settings, input system package, or excuse me, no, visual scripting, then come down to type options, scroll down, and we need to add the player input type as a type usable by the graph. So make sure we select player input, Unity Engine input system, and then we have to regenerate the nodes. And as we discovered last time, this is one of the great weaknesses to the visual scripting graph, is you have to constantly regenerate your nodes whenever you add new types or nodes, which is similar to anytime you add a new class script or change something in a script where you have to recompile. However, it really does seem like it takes a little bit longer going this route. So you have to be much more strategic in the long run about using the same nodes over and over as much as you can, which is very important for defining abstractions. Okay, so now that we have the type set up, we'll come back into our script graph, our pause screen script graph, go back to our scene variable, and for our type, player input type, we can now just type in player input. And now we have a player input type. It wants to know which player input type we're referring to, which is of course the player input we added to our camera. And of course it's actually not showing up here as a player input. So let me close the graph, double check if we have it, we do. And I will open up the pause screen graph again. And let me take another look here, and it's actually hassling me for some reason. So I'm actually going to try redoing this variable, see if that works. Player input of type player input, and it is on the main camera and it's not working. Let me see if I can drag it in here. So that's a little bizarre. It's for some reason it's giving me trouble here. See, the script graph is set up, the player input set up. Pause screen script graph. Pause screen UI. This is actually a little strange because for some reason the scene variable pause screen UI is actually not showing up properly. So I might have, for some reason, it's almost looking like the scene variables got messed up. And I'm not sure why that is. Because there's supposed to be a pause screen UI option here. Let me open up the game screen real quick. So this has the player input. Let me see, if I click on main camera and, no, it's on the pause screen script graph. Yeah, this should be working for some reason. I'm going to try reloading the editor to see if that works. Every once in a while, a raw editor reload fixes everything. So that's a little disappointing. For some reason, this is hassling me on referencing the proper component. So let me open this back up, and we'll take another look at the pause screen script graph, and take a look at the scene variable, and see now it has the proper variable. So a little bizarre. It's how it works. It's how it works every once in a while. You have to turn it off and turn it back on. So let's see now if I do the player input variable again, come in here, type player input, and now I can select the main camera. So, case in point, every once in a blue moon, you just have to restart the editor. There wasn't anything out of control with the process. The process was accurate, but it just happens every once in a while. You have to do that. So now that we've sorted that up, this allows us to drag the player input variable we created into the graph, and we can now connect it to this input port. However, because we haven't selected some kind of input action, this is going to be throwing an error. So the next step we have to do is actually gather this input action. And there are a few ways to do this. The solid way that I have found is simply add a new variable. So if we come in here and we say input action asset, and then we select a new type, input action asset. Once again, the type we're looking for, it does not exist yet. So I'm going to delete this variable. We need to click on edit and go to project settings, visual scripting, type options, scroll down to the bottom, add a new type, and that new type is input action asset from the input system. So add that type, regenerate nodes again. It's going to ditz around for a while and recompile everything. Okay, regenerate nodes complete, close this. So let's see if this works properly if we add a new variable. Once again, we're going to call it input action asset. Then we will select the type of input action asset. And the input action asset is actually on our player input object, but it's actually able to pull the asset itself. It doesn't have to actually come from the scene. So that's pretty convenient. It just grabs the player input asset. Now that we have this asset, we can drag it onto the graph. However, this alone is not good enough. If we go like this, even though it connects, that's not accurate, it won't work. This is looking for an action, not an action asset. So we have to come up with a slightly different plan here, where we actually gather the specific action we are looking for. And in order to do that, there actually is a convenient node using the input action asset type we just added. So we'll say input action asset, and we want to do something called find action. So we will pick this first option here, which allows us to grab an action through a name or an ID. And even though this has a flow input trigger and a control output trigger, I've found that we don't actually need to trigger these like that. So instead what we can do is drop our asset right here, which if you select the node and scroll down, target is an input action asset. And this is, even though it's returning an object, it is an input action asset. So we can drag this in here, and that's going to work. If we scroll down, we see that the output is an input action, which is exactly what we're looking for here, an input action. So these types align properly. And to pick the type we want, we have to pick a particular action name from our input system. So if we close this real quick and we go down here and we take a look, the one we're trying to target is toggle pause. So we'll open up the graph again, and in this action name we will simply type toggle pause. And then real quick, we will, let me grab all this, scooch it over, click on the clear errors, and this will actually clear. And now we're ready to test if this works or not. So I'll close this, save the scene. I will give it a second to stop thinking there, and then I will click play. Oh, actually, and I will go into the, or wait, hold on. I guess we should do it from the pause scene. So I'll start play mode in the pause scene. And if this works correctly, when I press escape, we should enter the game scene. Perfect. Now, if I push escape in the game scene, it doesn't go to the pause scene. And that's because essentially we have to recreate this behavior in the game scene. So the first thing we're going to do once we enter the game graph is we are going to have to do the same thing. We have to go to the scene and we need to actually make sure that we switch into the game scene. That way when we open up the game screen script graph, it shows the proper variables. And for some reason it is being a little weird here. I think that's just for artifacts from when I added them earlier. So the first thing we need to do, once again, is we need to grab the player input of the scene. So we'll say player input, select the type player input. Then we will grab and of course, for some reason, it is not working in this graph. And that might be because as you can see here, we have a player input. So what I'm going to do is I'm just going to delete the game screen graph since it's giving us trouble. And I'm simply going to recreate a brand new graph and give that a shot. So select the visual scripting, right click, create, go to visual scripting, and select a new script graph. And I'll simply call this the game screen script graph. Then we will open up the game screen script graph, select scene, and we're in the game scene. So now if I add a new variable, I should be able to say player input, and we should be able to grab the type player input, and we should be able to come in here and select the main camera, and this time it works. So I suppose what happened there was because I tried to go with the duplication route at the bottom, there were some kind of references that were being carried over, graph-specific references, and that was messing up the referencing. So good little lesson there for everybody. Make sure you just create a new visual scripting graph manually and don't try doing a duplicate because apparently it doesn't work very good. Okay, so now that this is actually set up to where we can grab the player input, we also need to once again, of course, grab the input action asset of type input action asset, and we can simply grab the player inputs asset. From here, we're going to need to drag these in to the scene. Then we are going to need to add the node for reacting to any buttons pressed on the input system, and that was, of course, once again on input system event button, since we're doing a keyboard button event. We'll select this. Our player input is right here, and to grab the particular action we're looking for, once again, we do add node, and we say input action asset, and we say find action. And make sure we use the one that allows us to type a string name, not the GUI ID, or not the GUID. So now we will plug the input action asset into this port. We will pick the action name, which is once again, it's toggle pause. We will drag this over and we will place that action into this port. Then we will do the same thing we did in the last graph, which was we are going to do scene manager, load scene. And we will load scene using a name. We will set up the execution port like this. And the scene name we're loading into this time is the pause scene. Clear the errors. Everything looks clean, so we'll close this. And as long as everything is referenced properly, when we enter play mode, we will now have a toggleable pause state, which will go back and forth between the game scene and the pause scene. So disregard these weird destroy media panel things, which is something to do with the UI builder artifact. It's inconsequential. Push escape. And I did mess up something. So let me take a look here. Let me double check the graph. On pressed, toggle pause, input action asset, player input, both from the scene. Scene name is pause. on pressed. Let's take a look here. We've got the event system that's set up. The main camera has a player input. Let me drag the player input up above the UI document real quick. Oh, so it looks like, okay, so here's what I forgot to do. A good little note. So the behavior was not happening because I forgot to add a script machine into the scene, since this was the first time we've actually worked with the scene. So I need to, real quick, once I select the main camera, say add component, and I need to add a script machine. Whoops. Not a script machine, not even sure what that is. Then we will click on graph and we'll make sure we select our game screen script graph. And that should actually fix it. Give it a second to recompile. And now if I push escape, we go into the pause scene, and if I click escape in the pause scene, we go back to the game scene. So now we have a quote-unquote toggleable pause. This isn't a functional pause though. There are a few other parameters that we need to set up to make this actually work as a pause. However, we have the button input set up. In the next video, I will get more specific with this for actually making this function as a pause, but for now we have it set up to where it's responding to the player input, which is what this video is all about. So now let me exit the play mode real quick and allow me to take a sip of water real fast. Alright, so that graph was actually pretty straightforward. Was not too complicated. Like I said, make sure you avoid that bug of using this. If you don't go down this route of actually plugging these ports in, there's a weird bug with this input system event button. I actually put a post up on the forum asking about if it was a bug, and I haven't gotten responses, so I wound up just finding a way around it. And now that I found a way around it, I'll probably update the forum post, but for now, this can still work. So whatever you bind into your input system, you can still use this node as long as you go down this route of actually manually hooking up these ports, which is much more convenient than trying to subscribe some kind of custom event to the input action asset. So I'm happy that I figured this out because this is much more convenient. Now that we figured this out, we have a little bit more work to do. And the work that we've got to do is actually respond the paddles to the inputs of going up and down, which is going to take a little bit more work than this graph right here. So I'm going to close this graph real quick, and I have to stipulate something. In the previous video, when we made the move player paddle and move opposing paddle, I made one action for moving the paddle, and then I set up 2 key bindings within each of the actions. However, upon experimentation, what I discovered is if you go down this route and you use the nodes in the way I've set them up, anytime you push up arrow or down arrow, it counts as the move player paddle action, so it's not actually able to differentiate them. I wasn't able to figure out a way to key into the binding property specifically. So the way we are going to solve this is we're simply going to split up the up and down buttons into their own actions. So the way we're going to do this is I'm going to select move player paddle, Control D, move opposing paddle, Control D, and then I'm going to very simply rename these. So we'll start at the bottom. So we will rename this to move opposing paddle down, and then we will remove the W binding. So now S is move opposing paddle down. So then we'll come to move opposing paddle, but we'll rename it to move opposing paddle up, and we'll remove the S key. And now we have a move opposing paddle down as S, move opposing paddle up as W. We'll do the same thing here. We'll make sure that we rename the move player paddle 1 to move player paddle down. We will remove the up arrow, and we'll do the same thing for here. We'll rename move player paddle to move player paddle up, and then we will remove the down arrow. If we do this, it becomes much easier to actually use the node to find the actions. So my apologies for this being a little different from the video a few videos back, but we've got to change these actions to make sure each binding has its own action in order to set this up properly. So now that we've done a little bit of that legwork, we can now come back into the game screen script graph. And I'm taking a look, and right now the video is at 25 minutes. I was planning on setting this up to do it like a long way and then a short way. If we do it the long way, there's quite a bit of nodes on the screen and connections, and the plan was to do that and then show you how to do subgraphs afterwards. So what I'm going to do is maximize this, and I'm going to try to blitz through actually generating all of the game controls that we need for moving the player paddle. And then we'll do the script graph, or excuse me, we'll do the subgraph afterwards. So the first thing we need to do is, of course, we are reacting to an input system event. So we need to come back in here and say on input system event button, which I was able to type OISEB and it actually came out pretty good. We will need to go through this process again, which is pretty simple because it's the same player input, so we can conveniently connect that. It is not the same action, so we will have to do another input action asset find action using a name. This will be the action we want. The action we're looking for in this instance is move player paddle up, and we need to make sure that the action name we type in exactly matches the action we're trying to grab from the action map. So now let's open up the graph again. And we are pulling this action from the same input action asset, so another instance where we can reuse our variable. Now that we have this set up, the next thing we need to do is actually incorporate some way to move the paddle. So this is the first time since I guess it was the third video where we created the rigid bodies and colliders for the paddles, where we're actually going to utilize the physics system. In order to move the paddle, we have to access the rigid body 2D of the paddle, and we need to set its velocity. This is going to make the paddle move. So in order to do that, we need to create a new scene variable, and that is going to be called player paddle. It is of type of game object. And once we select type, it will be the actual player paddle. We can then drag the player paddle onto the graph. And then there is a particular type we need to grab, which is the node we need to add is something called rigid body 2D rigid body 2D set velocity. So rigid body 2D set velocity. We'll grab this node. We will drag our player paddle into the rigid body connection. And even though this is a rigid body port and this is a game object output, this essentially is smart enough to do a get component for the rigid body 2D. So it understands that even though a game object is coming in, that you're asking for that game object's rigid body. So it's intelligent enough to set that up. The next thing we need to do is we want this to occur when this input system event button is pressed. So all we need to do is set the control ports like this, and it will actually work. The next thing we need to do is when we press this button, this is the move player paddle up. So up in the 2D mode is Y. So we need to set the velocity to move up in the Y direction. So we will come to our vector 2D here, and we will make the Y component 5. And this will set our velocity to go up 5. And click clear errors. And we'll give this a test. So let me close this, save this game scene, and let me enter play mode. And while it's recompiling, I'll take another drink of water here. And if this works correctly, when I push the up arrow, the paddle will move up. Ta-da! Look at that. Not only did it move up, but because we actually used the physics system and put colliders on the roof and put colliders on the paddle, we didn't even have to make the node check for a collision. The physics system automatically handled the collision for us and stopped the paddle. So we didn't have to define any custom behavior for stopping the paddle. We actually allowed the physics system to do that for us. However, now we have the paddle stuck on the roof, so we of course need to... Oh, and one other thing, real quick. If I go into play mode, I'm going to push the up key once and let go of it instantly. Watch what happens. So that's not what we want. When we release the up key, the paddle needs to stop. However, what we've done is we've essentially added velocity whenever we push the key down. So even when we release the key, the velocity sticks. So that's something we need to change in the graph, is we need to set it up to change the velocity back to 0 if we release the event button. So to do that, we have to, once again, grab one of these nodes, input system nodes. Let me full screen this. So right click, add node, OISEB, EB, on input system event button. And in this instance, we need to make sure that we change this on pressed option to on released. Then we can do the same thing, drag the player input variable into the player input port. In this instance, it is the same action, so we can conveniently reuse this find action option because it's the same action, but one of them is on press, one of them is on released, so that's convenient. And then we very simply need to grab another rigid body 2D set velocity node. So we'll say rigid body 2D set velocity, and then we will set that to trigger. We can reuse the player paddle object, and in this instance, we simply want to reset the object velocity to 0, so we can leave it as the base 0. And every time you set up every single time you set up an on input system event button, and you connect the player input, but you forget to connect the input action, it gives this little error that the player input's not going to execute properly. So you just have to click clear error once you've actually plugged it in. Alright, so let's close the graph again. Enter play mode, and if this works, I should be able to jitter the paddle moving up by clicking the button down and up. So here we go. So down, up, down, up, down, up, down, up. Okay, good. So that's exactly what we wanted. Now that we have that set up, open the graph again. And more or less, we just have to rinse, repeat this for all of the other states. So I am going to give this a shot real quick on copy pasting, which I know is risky sometimes using the graph, but for experimentation's sake, we will do that. Now that we have this copy pasted, we actually need to create another variable. Oh, not yet, because we're doing the down buttons. So in this instance, okay, so let me full screen this. Everything is basically the same here, except for input action asset, we need to make sure that we remember to connect the input action asset, which is the same input action asset here, so we can reuse that. We need to change the move pladdle. We need to make sure we move the player paddle up to player paddle down. Then we need to make sure that we're still using the player paddle, that's correct. However, in this instance, when we press the button, we need to make sure that the paddle moves down, so we make this -5. Otherwise, everything else is actually the same here. So let me minimize this, close it, and let's see if that copy pasted cleanly or not using the scripting graph. It should copy paste cleanly, but every once in a while it does not. Alright, so if this works, I should be able to move up and down. Alright. And there you go, we have a functioning paddle moving up and down. Very good. So, now that we're doing this, I need to point something out. Notice that every time the paddle is actually colliding with the wall, it's offsetting just a little bit. That's why you're seeing this slight pixelation. That is because it is actually calculating physics collisions on the spot, which is not what we're interested in doing. So there is an easy fix for this though, because essentially what's happening is it's rotating in a way we're not interested in. So real quick, I'm going to click player paddle, and I'm going to freeze the Z rotation. Then I'm going to come back over to the play mode and double check that it worked. And essentially now, if I start going back and forth like this, you notice that now that artifact is gone, it's not pixelating anymore. It's not rotating on the z-axis, which is exactly what we want. So real quick, I will click on the opposing paddle and I will do the same thing. I'll freeze the Z rotation. And now that that actually worked pretty cleanly using the copy paste method, I am going to, oh, and actually, now that I realize this, I'm going to delete this node and I'm just going to reuse this game object node because it's the same thing. It winds up being the same game object, so we'll just set that up like that for reusability's sake, and there we go. So now, all we need to do is grab these, Control D to duplicate, drag all of them down. Then we need to, I'm going to maximize this so we can drag this. We need to, once again, in our find action nodes, we need to plug in the actual input action asset so we can reuse our variable for that, plug them in. We need to make sure we rename these to move player paddle, or excuse me, change move player to move opposing. Move opposing paddle up, move opposing paddle down. Then we need to select our scene variable option, and we need to add a new variable, which of course is the opposing paddle, which is a game object, and it is the opposing paddle game object. Now that's done, we select this variable here and we switch this over to, and we would switch it over to opposing paddle, but it's being finicky, so instead I'm just going to delete this. Yeah, I'm just going to delete it and drag the opposing paddle in here and reconnect all of these ports to gather the opposing paddle's rigid body. Once that is done, the behaviors are all the same. It's very simply going to, essentially do all the same behaviors. So I'm going to minimize this. I'm going to close the graph, save the scene, and if all is well, we're going to enter play mode. We should have two separately controllable paddles. So up arrow, for a second there it didn't work. For up arrow, up, down arrow down, and W up, S down, sweet. So there you go. We have two controllable paddles on the screen. Very good, very good, very good. Alright, so that wasn't so bad. I'm at 37 minutes though. I'm still going to show you something. Even though we have this graph set up, it is kind of a daunting graph. It's not only daunting, but it's very repetitive. Like a lot of this repeats over and over and over again. So what I'm going to show you how to do is make something called a subgraph, which in visual scripting lingo is more or less a function. It allows you to create a graph inside of a graph that reuses the same functionality but has a few key input parameters that get passed around within the reusable code. So it's basically a function. So to generate a subgraph in a graph, the way we do that is we come over here and make sure that nothing is selected, so the left click. Then we will right click. We will go down to the nesting option, click on that, and very simply we will grab this subgraph option. And now we have a subgraph. So when I select this subgraph, I'm going to double click on it to enter it. That time it zoomed in, so I had to double click on it twice. Real quick, I'm going to give it a title. So the title for this graph, we'll say this is, we'll say move paddle on player input. Now that we have this set up, essentially what we are going to do is add all of the reusable parts to the graph. So if we take a look, I'm going to go up to the breadcrumber, click on game screen script graph. And then what I'm going to do is I'm actually going to right click on move paddle on player input. I'm going to say open in new window. This will allow us to go back and forth for reference sake on what is repeatable in the graph. So let's take a look at what we can do. One thing that gets repeated over and over is we reference the player input and an input action for all of these on input system movement buttons. And in this instance, the we have 4 cases of the input system having a pressed and released state. So the first thing we're going to do over here on our subgraph is right click, and we're going to add that on input system event button node. We will duplicate it, drag it down, and we are going to set one to on pressed, set one to on released. The next thing we're going to do is we need the player input reference, and because every single one of these, and I'm actually looking at it, for some reason it actually broke the connection. Maybe when I duplicated it. Huh. So that's actually kind of interesting. It didn't actually need the player input variable. Let me double check if that's actually true. I might have learned something new here. Yeah, that for some reason this port wasn't working properly in a different testing, so okay. So that's actually pretty cool. So the bug is only on the actual input actions for some reason. So that's very convenient to, it's actually very convenient. So let me open this back up now that I've played around with that. Pull this back open. And from that assumption, we actually don't need to hook up these input ports, these player input ports. So we're going to leave this as this, and that will assume that it's talking about our main camera's player input component. So that works out pretty good. The next thing we have to do is we have to once again find the input action. So to do that, we will right click and we're going to say input action asset, so IAA FA for input action asset find action. Pick one with the name. In this instance, it's the same action. It's just a different response for pressed or released. And we have to grab the actual input action asset. So for that, we can go to the scene variables and we can grab the input action asset we were originally using. Plug that in. Okay, so the next thing we need to do is we don't want to sit here and type this string every time within the graph. That's not how we want this to work. Instead, what we want to do is from the subgraph, we want to plug the string in. So to do that, when we're in the subgraph here, go up to the Subgraphs graph inspector, and we need to click on data inputs and create a new data input. So click on the plus sign for data input, and for key we will simply call this action name, and we will simply call the label the same thing, action name. And let me drag this down so we can see it a little bit better. And for these type, we will click string. And notice that once we added this input string, our input node, which previously had been unused, now has an action name option. We will drag this action name into the find action name port. And when we take a look over here, we also now have an action name on our subgraph. If we zoom in, it doesn't give us the option to add the name manually. There might be like an attribute or something to make that work, but the way we're going to do this later is just use the string literal. So now that we have this set up, what we are seeing here is that we are now grabbing all of this functionality by very simply making a subgraph and plugging the string in. So we can make 4 of these subgraphs and make 4 strings and just type 4 separate strings, and we don't have to recreate all of this over and over and over. So now that we have that set up, the next thing we've got to do is once again set up the actual reactions for how the paddle interacts with its rigid body. So this stuff. So the way we're going to do that is we'll right click, we'll say rigid body 2D, set velocity. We'll add a velocity component, we'll duplicate it because we will need 2 of them. Connect to the trigger ports. On release, we want it to hit 0, so that's pretty solid. On press, we do want to change the velocity in the Y direction. However, we don't want to sit here and manually do it inside the subgraph. We want to, once again, we're going to add a port for the outside of the graph. So to do that, come back over, once we're in the subgraph, go to data inputs, and we're going to add a new data input, push plus. And this is very simply going to be called paddle velocity. We'll name the label the same thing. Drag it down here, and the type we're selecting here is not going to be a vector2. The type is just going to be a float. This allows it removes the ambiguity of which direction the paddle is moving in, and just gives us the ability to define the paddle speed, but define the paddle behavior inside the subgraph. And because we added that, we now have the paddle velocity input port conveniently added onto our input node. So the next thing we need to do is, of course, convert this into a vector2. So you might argue that you might as well just create the vector2 as the port, but I like doing it like this because that is going to allow us to vector2 create vector2 of the xy type. If we do it like this, once again, it's a good showing of how we can contain certain behavior inside the subgraph and make the control values less ambiguous. So now that we have the paddle velocity set up, we never move the paddle in the x direction, we only move the paddle in the y direction. So we will connect the paddle velocity port into the y, and then we will move the vector output into the vector input for the set velocity on the pressed option. On release, it always hits 0 anyway, so we don't have to connect anything into this port. We just very simply use a variable for the on pressed option. Now that we have that set up, the last thing we need to do is set up which game object actually receives these commands. Previously in this graph, what we did was we differentiated between the player paddle and the opposing paddle. However, we don't want to differentiate on that inside of this graph because it's not reusable. Therefore, if you've been paying attention, you guessed it, we need to add a new data input of type, oops, let me scooch this down just a little bit further. So the key for this, we're just going to say paddle to move, and we will put the same thing in for the label, paddle to move. And the type of this is game object. So now we have a game object port, and in this instance, this game object is going to get plugged into both of these rigid body options. All right, and that is the completely variable subgraph now. So now I'm going to close the subgraph, and I'm going to come in here. And I know it's a little intimidating to do this, but we are going to now grab this entire group here and delete all of it. And then we're going to maximize this graph, zoom in, and we're now going to take a look at our subgraph. So move paddle on player input. So we need to, the first thing we need to do is select the graph, right click, and we're going to type in string literal and pick a string literal. Plug it in. And the very first one we'll do is, of course, and this has to match exactly with the action name in the input system, but the first action name we will go with is move player paddle up. We then need to pick a velocity for the paddle, and the velocity I've wound up going with, which if you click on this node, drag over, left click, it actually will give you some suggestions, and in this case it's correct, float literal. So select float literal, and for moving the player paddle up, we want it to move up by a velocity of 5, so we can just pick a float value of 5. As for the paddle to move object, in this instance it is the player paddle, so we will once again go to this, right, or we will select the nodule, drag over, left click, and in this instance we don't want a game object literal, we don't want to create any game objects. We instead want to go down to variables and select our scene variable and say get, and it's actually not showing the proper paddle, so let me click on scene, and for some reason it wasn't showing up, so we're just going to drag it over manually. In this instance it's the player paddle, so we'll plug in the player paddle, And just to make sure that this is working, we will minimize, close. And if this is all connected properly, upon entering play mode, the paddle should have the correct upward movement parameter. So when I push up, it should move up, good, and when I release it, it releases, so very good. So that's exactly the behavior we used to have. And now you're seeing why this is so convenient. If I open up this graph, as before we had that, it was a pretty vast graph just for moving like 2 paddles around. A lot of connections. Now what we've got is a reusable graph. So if I come in here and I duplicate it, select them all, duplicate them again. Now instead of running through, creating all those new nodes, renaming all the values, making sure everything is hooked up properly, I can just very simply come in here and tweak these parameters. So in this instance, we don't actually need a second one of these because it is the same paddle in this instance. For moving the player paddle, in this instance, we want to change it from up to down. And to move it down, we want the velocity to be -5. By the same principle, right here we're changing move player, but it's not player, it's removing the opposing paddle. So move opposing paddle up 5, and it's not the player paddle. Grab both of them, delete them. It's not the player paddle, we need to make sure we go over here and grab the opposing paddle. Connect the opposing paddle to the paddle to move option. Jump back into the move player paddle down option and change it to move opposing paddle. And make sure it changes to down. So now we've changed, oh, and then make sure that we move it down. Right. So to effectively connect all 8 of those behaviors, which is starting and stopping both paddles moving up or down on key inputs and key releases, all I had to do was copy the subgraph and tweak a few of these strings and floats and make sure that the proper objects are hooked up. This is probably Visual Scripting Graph's saving grace, because in normal code, it's very easy to not refactor like that. However, when you have that whole gigantic graph spit across the screen, it's very, very easy to see your potential reusability. It's not as easy to see that reusability purely from code. So it's my hope that in the long run, visual scripting is going to help me actually be a more diligent refactorer, with how nifty it is to just see the refactors, generate a new graph, and just like whip up everything and put it together. And then the reusability is also very nifty. So I'm really hoping that that will actually wind up being a positive in the long run. The other thing I wanted to mention is that, and I actually it kind of slipped my mind what I was going to say, but the other thing is that over time, as you start to build up more and more of these reusable subgraphs patterns, you start to reuse them in your game code in more and more places. So you have to do regenerate nodes less often, and over time you wind up having more and more nodes like this to reach for. Whereas it's very easy in normal code to like get stuck into the copy-paste mindset, which is very nasty at creating dependencies. And it's very easy to make it harder to refactor. But with how straightforward it is to just see a pattern and refactor the pattern, I am really hoping in the long run that this is kind of the key of what's great about Visual Scripting Graph. That it will allow for, it essentially helps with dependency help. That is the primary reason why I wound up trying to go down this route. Alright, so thank you for putting up with that aside. Let's close the graph and let's do a final test on all of the player inputs actually functioning. So in enter play mode, give it a quick moment to recompile, and ta-da! All player inputs are still valid, and properly collides with the colliders using the physics system as it's supposed to. We froze the Z rotations so it's not having that weird artifact where it's pixelating. So that's it. That's how you can use the Visual Scripting Graph to create the ability to move the paddles in Pong. Alright, so one thing I need to cover before I end this video. Let's say I move the opposing paddle all the way up, move the player paddle all the way down, and I decide for whatever reason I need to pause, so I push the escape key and pause the game. Okay, so that's how that's supposed to work. However, note what happens when I re-enter the game. The paddles have reset to their default position. And this makes sense because what it's doing is it's reloading the scene. It's reloading the game scene using the game scene's base parameters. So it makes sense that this is what's happening, that it's resetting all of the values. But in the long run, this is also going to reset where the ball is, and it's going to reset the score. So it's not the behavior we want. However, the whole point of this video was to cover setting up all of the player keyboard inputs specifically, which we accomplished. W, S, up arrow, down arrow, escape, escape. Those were all the input actions I wanted to cover. So for now, that is actually the end of this video. If you enjoyed this content, if you found it useful, if you appreciate what I'm up to, don't be afraid to like, share, and subscribe to my content. And as always, I always love to ask, if you have the chance to support me on my Patreon, please go and support me on the Patreon. That helps out a ton. So, in the next video, I'm going to wrap up the rest of the game behavior for this Pong recreation series. We are going to give the ball its initial velocity. We're going to give it its initial trajectory. We are going to make sure the ball reflects off of any colliders it hits, which is the roof, the floor, the two paddles. We are going to make sure that if the ball hits a goal, the ball resets to the middle of the screen and continues moving. If the ball crosses a goal, it will apply a score to the proper UI score for the correct player instance. And in the event the score is over a defined win value, we will transition into the result screen. And if the player won, we will say victory. And if the opposing paddle won, we will say defeat. And the only other thing will be setting it up to where if we pause the game and come back into the game, everything is actually where it's supposed to be. So the paddles will be in the same spot, the scores will be the same, and the ball will be in the same spot. And we can actually do that using the scripting graphs built in, not saved, application variables, which they go beyond scenes. So essentially what we can do is just make a bunch of variables to save the positions of everything in the game. And when we pause and go back into the scene, into the game scene, it will just make sure everything initializes where it was at. And I'll probably do a little bit of research. There might be an even easier way to do it where I simply like persist whatever the scene data is as opposed to load the scene fresh. So that is actually it for this video, and I am excited to finally complete the game mechanics for this recreation series in the next video. If you are interested in taking a look at that, make sure to check it out. Take care.